you know how in past units we learned like different ways to solve, and then we put them into a graphic organizer eventually, and we have like solving, if it's this situation, you solve that way. If it's this situation, you solve another way. If it's this situation, you solve another way, right? Sounding familiar? Because we learn all these different strategies depending on what we have, right? Depending on the situation. And the reason we do that is because at the end of the unit, we feel really good about each one, but then we mix them all up. We put them all in the same worksheet. And it's like, well, I don't know which one it is, right? And it helps us kind of be like, oh, it looks like that one, so I'm going to do this strategy, right? Now, this will be number one in that graphic organizer. So this is today's lesson is your first strategy for solving. Now, I'm phrasing it that way because I think we've struggled with the identifying part. I want you to have that in your mind as we go through this. Look for things that are clues, right? Oh, this one always has the same base on both sides or something like that. Start identifying the situation now so that when we mix them up, you can tell the difference between them, okay? Now, before we get started with that, we have a little bit of like a random puzzle. You might be like, what? Does this have to do with anything? As always, trust me on this one. All right, so I want to rewrite these both as same base, but with an exponent. So what do you think 4 and 16 could be rewritten as? Hold on, one person at a time. Go ahead. 4 to the 1 and 4 to the 2. Anybody get a different answer? 2 to the 2 and 2 to the 4. Both true, right? We get it? All right, so what's our strategy here? What was in your mind? You're thinking to yourself, first, well, what number goes into both of them? 3. And then you ask yourself, can I raise 3 to a power to get both of them? 3 to the what is 27? 3. 3 to the what is 81? 4. Okay? We need this skill today. One more. 25 and 625. So first I got to think what goes into both. 5. And then can they both be rewritten as 5 to the something? 5 to the what is 25? And 5 to the what is 625? 4. Anybody get another answer for this one? Whole numbers. 25 to the 1 and?
25 to the 2.
Yep. Because if it's 5 to the 4, then it's 25 to the 2. Okay. Why do we need to know that? On to the situation. Now, I'll give you a few examples that are simple, and then we're going to obviously get a little harder to... You were, yeah. But I want to explain the logic that is happening so that we can apply it to harder problems, okay? So, you might look at this problem and be like, 3 to the blank is 9. I know what that is because I know how to get from 3 to 9 by adding an exponent. What is that exponent? 2. But let's pay close attention to what's going on in our brain there because we're going to need that process on paper for harder problems. What we're saying to ourselves is, well, 3 to the x on this side, this 9 can be rewritten as 3 to the what? 2. And we know that this equal sign means that they are the same thing on both sides, right? And if this is 3 to the something and this is 3 to the something, and that's all that's on both sides, don't these things have to be the same thing? Yes. So therefore we say, okay, I just know for a fact then that just by thinking it through, I haven't really done any solving other than to just use my brain and say, I know it must be 2, right? And these 3 dots just mean therefore. Therefore, it must be 2, okay? That's kind of where we got to go today, and then it'll get a little bit more complicated than that, but that's the basic concept. So let's try that a few times. So your process is you look at both the numbers just like we did in the warm-up, the first part of the warm-up, and we say to ourselves, could they be expressed with the same base? So I got 2 to the x, and how could I rewrite 32 as 2 to the something? 2 to the what? 5. And once you get it that far, same base, right? You know that these have to be the same. Therefore, you know that x is 5. Therefore, x equals 5. You can, if you want, you could say 2 to the x equals 2 to the 5. And because the exponents are the same on both sides, I know that x must be 5. No, because you're not connecting this. You started a brand new equation. How did you get there? Okay. 10 to the x equals 1,000. So 10 to the x, and then let's kind of go to our brains and be like, can I rewrite 1,000 as 10 to the something? What? 3. So therefore, x equals 3. Can't believe you're giving me grief about 3 dots. It's just 3 dots. That's the easy way to do it. All right, now, to this is a therefore point, to explain that further. The reason that I like the therefore is because think about when we usually solve. We divide both sides. We add to both sides. We square root both sides. We raise both sides to the 1/5. We show our work, right? We show the process. In this, we're literally just saying, I know in my brain that this is true, right? And you have to have a way to show that on paper. Now, the other part of that is you can't just do that without a property backing you up. When you're using your brain to just be like, I kind of just know this is true, there needs to be a property that backs you up, and that property is about to be described to you. Okay? This is called the common base property of equality. So common base, so common means same, right? Base is that bottom of the exponent, right? And equality, of course, is an equal sign. So if you're just kind of dissecting this, you'd be like, all right, same base, and then there's the equal sign in the middle, right? So same. If you ever have this situation, you can use this property. Now the property says a to the m equals a to the n. Sorry, if a to the m equals a to the n, then we know that m equals n. Okay? If you have the same base and different, well, they don't have to be different. They could be the same too. But you have exponents. Those exponents have to be the same thing, right? They must be true. Okay. In words, we would say if bases are the same, and they got to be the same. Can't do this if they're not. The exponents are equal. And why is that useful? You can make a new equation. Okay? Now, typically I give steps out sparingly because I think when we focus too much on steps, we forget about the concept and then we get stuck when the problem looks a little different. But this is a good place for steps, so I'm going to give you some steps here. Your first step with any of these problems is you need to get those common bases. So you need to rewrite each side to get common bases, or the same base. So the problems up above, they kind of were almost done. Like, you're going to have a little bit more work to do, okay? And then once you've done that, you want to make a new equation with the exponents equal. Okay? So we'll look at some examples. So I'll give you like your kind of thought process here, and then you don't necessarily have to do the parentheses I'm about to show you and all that, but I'm kind of show you what you're doing here, okay? So let's lock in on this one. Okay, now the first thing you got to do is kind of just assess your numbers, kind of like in the very first warm-up. Like if I have 125 to the x equals 25, right? But I want to rewrite 125 and 25 so that they have the same base and are raised to an exponent. What could I do? 5. 5 goes into both. 5 to the what is 125? 3. And 5 to the what is 25? 2. Okay, now after you've plugged in the replacements, right? Now you got to kind of take a look at what happened, whether there's some simplifying that needs to be done or whatever. Because look at what happened here. Now I have 5 to the 3 to the x. What is that? Because it was 125 to the x. Well, now it's 5 to the 3 to the x. What kind of situation we got here? You said 5 to the 3x. Why?
Because you multiply the 3 times the x because it's outside the parentheses.
Yeah, it's a power to a power. That's multiplication. Yep. So it's 5 to the 3x, and then over here it's just 5 squared, so we can just write 5 squared. Now look what we got. Same base on both sides?
No. Oh, yeah.
Yeah, 5 and 5. This is a little trickier to see because it's like, okay, well, it's not as clear as just x, but it's still true. If you got 5 to the something and 5 to the something on both sides, well, those somethings have to be the same. Like 3x is 2 and 2 is 3x. That has to be the case. Does that make sense?
Yeah.
If I got 5 and I'm raising it to something, and 5 and raising it to something, and the result is equal, don't they have to be the same thing that I'm raising them to? Don't they have to be equal to each other? Okay, well that means we make a brand new equation with that knowledge. With that knowledge that 3x must equal 2. And we solve that equation. Okay, so I would divide by 3, and I get x equals 2/3. And like any good solution, you can check your work, right? If I raise 125 to the 2/3, I would get 25. You can do that both with your calculator or without, right? But that would be true, okay? I would show you, but we're short on time. All right, this one. 4 to the x, 16 to the x minus 1. I got x's in both situations here, okay? Now, looking at just the number for a second, 4 and 16. What could I rewrite them both with base-wise? 4 or 2. Now, in this situation, both will work, but don't do more work than you need to. Is one of them already 4? Yeah, so let's just leave it as 4. Let's choose 4. So 4 to the x, and then this one, I'll leave a space for 16, and it's going to the x minus 1. Now, what do I rewrite 16 as? 4 squared. Okay. Now, on the left side, I got 4 to the x. On the right side, I have 4 to the 2 to the x minus 1. What do we do with a power to a power? Multiply. Okay, so it's 4 to the 2 times, what's my other power?
X minus 1. Yeah.
Just x?
Minus 1.
It's the whole thing, right? So multiply by the whole thing. That will be the biggest mistake that is made. No parentheses there.
Could you argue that you don't have to because the x minus 1 isn't in a parentheses?
It's the same as if you, it's a good point. It's the same as if you had like x plus 1 divided by 4. Remember we changed PEMDAS to GEMDAS because groups have the same thing as parentheses. Sometimes the parentheses are just invisible. It's a good point though. Okay. Now, this becomes 4 to the x equals 4 to the 2x minus 2, right? And at this point, once you get those common bases, they kind of drop away because you know that if you have the same base, that this must equal this. So you say, okay, x equals 2x minus 2, and you solve that problem. Okay? So I minus 2x on both sides. I get minus x equals minus 2. X equals 2. Okay?
Is it minus? Oh,
Yep.
we do another one.
Now, how do I know I did it right? Yeah, I can check it. 4 to the 2 is what? 16. 16 to the 2 minus 1. Well, 2 minus 1 is? 16 to the 1 is? 16. So it's correct. It's a sloppy X. What's that? You'll find out. All right. Yes?
Why are you dividing by 1?
I divided by negative 1 because I ended up with negative x. X minus 2x was negative 1x, so I have to get rid of the negative. All right. A couple more, and these are a little tricky, I'll be honest with you. But the last couple classes, we're able to come away confident, so I think you will too. All right. Focus on the numbers for a second. 2 and 32. You start thinking what your base might be. 2, all right? So we're going to stay 2 to the x. Over here, we'll leave it down there and say, instead of 1 over 32, we have 2 to the 5th on the bottom, right? Does that make sense? Okay. Now, these are not common bases yet. Common bases have to be on the same floor. Okay? Make it negative. Now, that is confusing for some people because it's like, I thought we didn't want it to be negative, right? I thought we felt negative, so we went downstairs, or we felt negative, so we went upstairs. Yeah, that was what we were doing before, but now we want common bases. Now I need them on the same floor. So think about it. If you were negative and you went downstairs to get positive, but your mom said, get back upstairs and clean your room. Go back upstairs and you're negative again, okay? You can go backwards, right? So now 2 to the x equals 2 to the negative 5 is totally a fair move here, right? And once I do that, what do I have? I have my common bases. So I know that x equals negative 5. Was I in the way?
You make a very great wall.
I'm sorry. I try to switch it up. I'm always blocking somebody, it feels. All right. Does that make sense? Okay. It can get even more hidden than that. If we're looking at this one, well, 1/3. What is 1/3 but 1 over 3? And 3 can be rewritten as 3 to the 1. So really what I have is 1 over 3 to the 1. Think about what we just did there. I had 1 over 2 to the 5, and I moved it up. What could I move this to be? If I move the 3 up top, it becomes 3 to the negative 1. And over here, 27 is 3 to the 3rd. Power to a power, what's negative 1 times x? Negative x. So I get 3 to the negative x equals 3 to the 3. Therefore, negative x equals 3, right? And I don't want negative x, I want x, so I divide by negative 1, and I get x equals negative 3. Okay? So sometimes you got to play with those negative exponents. All right, couple application problems, and we will get to your homework. Okay? Ready? All right. I'm pretty proud of these problems. I made them this morning. Okay. Michelle has an Instagram page she is trying to grow. She posts a picture and 500 people like it. It's pretty normal for her. No big deal. Personally, I'm lucky if I get 100, but it's okay. I got Instagram way later than you. I get it. Anyway, as time goes by, she notices that her likes are doubling every week. This picture is taking off. How many weeks will it take for her to get to 32,000 likes? So, what are we dealing with here? Growth or decay? Growth. All right, so we have y equals ab to the x. They didn't give us a percentage, right? So we know we can just go right to b. Y equals a equals b equals x equals. What do we have an n value here?
Yes.
What is it?
32,000.
32,000. Starting value?
500.
500. What's our multiplier?
Nothing.
2. It's doubling, right? Doubling. And then it's x is our time. That is unknown. So now we plug in. I say 32,000 equals 50 times 2 to the x. And 500, forgot how popular she is. 500 times 2 to the x. Okay, now, what do I do?
Divide by 500.
Divide by 500.
You got, what do
64 equals 2 to the x. What could I rewrite 64 as in terms of 2 to the something? 2 to the 6 equals 2 to the x. Therefore, x equals 6 weeks. So in 6 weeks, she will be an influencer, getting ad payments and all that stuff. It'll be great. All right.
Next one.
Now, for the last one.
No, you want wigs.
This is a picture of me in my 20s.
Are you sure you have those online?
Yes, I haven't aged besides the hair, unfortunately. You know, somebody asked me earlier today, she's like, have you always been bald? And I said, do you mean like since birth? And they're like, yeah. I'm like, no, that's not how it works.
I had hair once. Long.
I had hair.
Long.
I can prove it. I had pictures. So anyway, I'm upset about my baldness. So I met a genie and I made a wish. And it's not going well. I've got problems. Something weird is happening. The length of my hair is growing by 200% a month. That is not a normal rate, folks. That is a lot. I keep cutting it, but it keeps growing. I cut it today. It's now 4 inches long. How long will it take for my hair to be 8,748 inches long, which is, I think, about like 700 feet, something around there. Yeah. Yes, pretty much. I would start a nonprofit and just cut my hair every couple hours and sell it not sell it, donate it. Donate it. Okay, so anyway, let's write an exponential equation. So, are we growing?
Yes.
Okay, so is it by a rate or is it by a multiplier?
Rate.
A rate. So it's y equals a times 1 plus r to the x, right? That's what we're dealing with. So we need to find those pieces. Sorry, zooming back out. So y, a, r, and x. What's the n value? 8,748. What is the start value? 4. What is the rate? 2. Very good. And what is the x? We don't know. It asks how long. How long? So we plug in 8,748 equals 4 times 1 plus 2 to the x. Okay? Notice what you end up multiplying by. 3, right? A lot of people, they see the rate, they just plug in 2. You are multiplying by 3 if you're going up 200%.
Yeah, it's 3.
If you go up 100%, you double. If you go up 200%, you multiply by 3. Question?
It says grow by 200%, not an additional 200%.
Correct, but that's what multiplication does. Think about after 1 year, 1 month, it'll go from 4 to 12, right? And then exponential growth won't go back to the 4. It'll multiply 12 by 3. So it's always 200% of whatever the previous month ended with. Does that make sense? That's why we use exponential growth, so that we can just do it all the calculations in one exponent. Okay? I'm happy to explain it more after this if you're still unsure after we go through the problem. Okay, so let's clean this up. 8748 equals 4 times 3 to the x. Now I would divide by 4. I get 2,187 equals 3 to the x. Now, at this point, you got to pick up your calculator, unless you really know your threes. Up to the 7th. Like, if so, good for you. Maybe you should be up here teaching, because I don't. Okay? So pick up your calculator. Don't be like, I don't know it, therefore I'm stuck. Start going 3 to the something, 3 to the something else, 3 to the something else. And if you do that enough, you will find that you could rewrite 2187 as 3 to the 7th. So 3 to the 7th equals 3 to the x. Therefore, x equals 7 months. I got time. After 1 month, it's only going to be 12 inches. We'll be fine. But unfortunately, I can't really keep up with those haircut bills.
Is that today's picture? You're wearing the same shirt.
I did this morning. It only took me like a minute. I was pretty impressed with myself. So exponential applications, and specifically when you had to find r and t, right? It's y equals ab to the x, or y equals a times 1 plus or minus r to the x, or to the t, right? We change the letters a lot, which is confusing, I know. But specifically, are you finding your percentage rate? Are you finding the time that went by? Because the first lesson we did was just about that starting value and that ending value. Now we're switching it up, right? So that's what this homework was allowing you to practice, right? And a couple problems at the beginning to get the skill locked in, but then it was mostly word problems. Can you set up this equation given words and then solve it, right? That's half the skill sometimes. Can I set this thing up? Or can I only solve it when it's written as an equation for me, right? So, anybody want to see 1 or 2 before we just dive into the word problems? So one of the equations on their own, no word problem. Yes, no, 2? All right. 2. All right, so this is kind of written weird. And in fact, I don't like this font enough that I'm going to write it over here again. 1,500 times 1 plus x to the 6.5 equals 1,525. All right, so we want to find x, right? And spoiler alert, that's soon going to be an r in these problems. We want to find x. So we got to break into this thing, but there's steps before we can do that, right? We can't have anything multiplying by it. So we got to get rid of that first. So what do? Divide. Yep. I got to divide by 1,500 on both sides. When I do that, I get 1 plus x to the 6.5 equals 1.02. Okay. Now, if this said something to the 6, and I told you you need to do the opposite of raising to the 6, you would say 1 over 6. It's no different now that there's a decimal. The opposite of raising to the 6.5 is 1 over 6.5. So I would raise this to 1 over 6.5 on both sides, and I will surely need my calculator for this. Okay? And on one side I get 1 plus x, and on the other side I get 1.003. Now I just need to get x by itself. Subtract 1, x equals 0.003. Okay? So that's the mechanics of the math. But can we set up the equation? So why don't we go to the back where they got a little harder. Anybody have any problems in the back they would like to see? 9. All right, 9. A recent college graduate decides he would like to save $20,000 or have $20,000 in 5 years to make a down payment on a home. How much money will he need to invest today in order to have the $20,000 in 5 years, given that he can invest at an annual interest rate of 4%? Okay, so what we always do is our little analysis. Okay, first of all, this thing is going up or down? Well, he wants to save and go up, right? So it's going to go up. So we know our equation will be y equals a times 1 plus r to the x. And now we think about what pieces we have, what pieces we don't. Y equals, a equals, r equals, x equals. What do I got? What do I not have? Okay, so y is the amount at the end of the situation. Do we know that? Yeah, he wants to have $20,000 at the end. So we know this, $20,000. A is the amount to start with. Do we know that? No, it's asking that. It's saying how much money does he need to start with in order to do this? So we don't know that. R is the percentage rate that this thing will increase. Well, R is just 0.04. 0.04. But you're right, that means our B is 1.04. So you could just jump right to your B. That will end up in there. And then your X is your time, and it said 5 years. So if you break it down this way, you've turned it into math now. So now I say, okay, 20,000 equals, I don't know my A, so that's staying, and then 1 plus 0.04 to the 5, and then sure, that becomes 20,000 equals A times 1.04 to the 5. Okay, I need to solve for A. What's happening to the A? It's being multiplied. It's multiplying by this thing, right? So I should divide by that thing. 1.04 to the 5th. And over here, 1.04 to the 5th. Throw that all in my calculator. And 20,000 divided by 1.04 to the 5th, enter. And I get $16,438.54. So that is the amount he would have to invest if he wanted to grow over 5 years to 20,000. You notice it's not that much more. He doesn't get that much more because he's only growing by 4%. Because that's the kind of what you get if you're only going to give him the money for 5 years. Yeah.
I think the real question is, where is he finding a house that only has a $20,000 down payment?
He doesn't live in this state. He lives in North Carolina or something. I don't know. I don't know housing rates. Maybe that's expensive too. Okay. All right. I think we got to move on since we have about one more problem. We can do one more. 8. Good. 8's a good one. Okay. You would like to invest $9,000 in a money market account, and you want it to double in 20 years. What annual percentage rate is required? Okay. Well, if it's doubling, is it going up? So it's y equals a times 1 plus r to the x. Okay. Y, a, r, x. Okay. We would want $9,000 to double 20 years from now.
1,800,000.
Yeah, so double 9,000 would be 18,000. So that's our final amount. Our starting amount is 9,000. What's our rate? We don't know. Question mark. And how many years? 20. So I plug in my pieces. I leave the piece that's missing. Okay? So y equals, not y, we know that, 18,000 equals 9,000 times 1 plus r to the 20th. All right, I'm trying to get to that r. What I need to get rid of first?
9,000.
Yeah, I got to divide by 9,000. I get 2 equals 1 plus r to the 20th. Okay, I need it to not be to the 20th. I need to get rid of to the 20th, so I raise it to the 1 over 20 on both sides. On the left side, 2 to the 1 over 20 is 1.0. I got 3.5. Yeah. And then on the other side, I have 1 plus r, right? Minus 1 on both sides. We get r equals 0.035. So if we were to tell this guy the rate he should ask the bank for, what would we say? 3.5%. Okay? All right. Now we got to move to the notes. So go ahead, grab your notes. All right, so what I will say